very much for the introduction. And also, who of you actually uses change data capture in your systems? Okay, few people. Cool, thanks. Yes, so again, I'm Michal, and
I'm Vanessa.
We work at a company called Anjaro. It's a French software as a service that provides some work management system for large and medium organizations. Mostly we help organizations to find the replacement if somebody cannot show up for work. And if you follow the news, then you probably know that working and not working is a very hot topic in France right now. But burning one, we could say. But actually, we will not focus that much on that. Mostly we'll talk about Elixir and Debezium.
But still, as Michal just mentioned, this is a picture of Paris a couple of weeks ago. That could also be a very good metaphor of us standing next to our technical debt at the beginning of last year. Maybe it felt knowable by you. Have you ever worked with multiple applications sharing a single database schema where you were not allowed to change any column name or their type because something somewhere could break and you wouldn't know why? Well, that was our situation. We were tasked to work on the search system that was reading from that schema. The existing system became really slow, really fast, and we were tasked, sorry. The existing system became really slow, and we were tasked to make it faster, but also to support much more data and new use cases. We knew it would be really difficult, because with the way data was modeled in our system, it will be a mess. So the best way would be to build a new model. We are not working from Elon, so how often can you pause the whole world for 2 years and rewrite the whole system from scratch? It may feel tempting, but more often than not, it's not possible. And it certainly was not possible in our case. Fortunately, there is another way. Martin Fowler came up with a name for it, the Strangler fig. That is the beautiful plant you see on this picture. This tree multiplies in a very peculiar way. Each seed lands on the branches of existing trees, and very slowly, the new trees grow on top of their older generation. And as those new tree generations grow bigger, the older generation dies, which is kind of sad, but it's also how you can progressively replace your software system. And that's the way we have chosen. But as you have 2 generations of the system running at the same time, you need to face a challenge of sharing state between those 2 systems. And to avoid mistakes learned from paying the past technical debt, and trust me, we had a lot, this time it will be better to have more independence and low coupling. And it's clear that databases are a poor choice for data integration between applications. But what would be a better choice? Message brokers would be. All right, so we have a database, possibly a very, very messy one. And we wish to turn it into a messaging system so we can send its data to some other place. So then on the other side, we could create our perfect model that suits exactly our needs. But how can we achieve that? Well, it turns out this is exactly how change data capture works. And in the rest of this talk, we will tell you how to use this pattern with an Elixir-based application.
Okay, so this talk is divided into 3 parts: data, capture, and ordering. First, we will explain a little bit what change data capture is, so how does the data from the database ends up as messages on the message broker. We will then talk a little bit about capturing this data in an Elixir project. And finally, we'll dedicate a bit of time into the topic of ordering, so how to consume this data in the right order and avoid race conditions. Okay, this is a table. It has rows and columns. But how does the information actually enter into it? Well, databases have this internal component called Transactional Log. So whenever you do any data modifying operation like insert, update, or delete, it is implicitly or explicitly wrapped within a transaction. And each new transaction ends up at the end of this transactional log. Then database builds its state based on that. Transactional logs also allow the logical replication to work. So in this setup, when you have multiple database nodes, usually you only have one leader node that receives the write operations, and you may have multiple read replicas. What actually travels from the leader node to all its followers are the new entries on the transactional log. And then read replicas build their state based on that. Okay, so that's how databases work, and that's the most reliable way of replicating data. Wouldn't it be cool if we could participate in this mechanism? If we could pretend that our own custom application with its own custom data store is just another read replica for our database? Well, actually, we can do that because transactional logs are accessible to us. The only challenge is that they are not really easily accessible. So, for example, in Postgres, the transactional log is called WAL, or write-ahead log. In MySQL, it's bin log. But of course, the differences don't end at naming. Like the format is completely different, and it's binary, it's custom, it's not supposed to be really accessed by outside of the database. But fortunately, there is a project, a leading open source project in the space is Debezium, and it actually understands all those custom formats for really many databases, not only Postgres or MySQL, also MongoDB, Oracle, and so on. So it follows the transactional logs for each of those database systems, and for each upcoming event, it publishes a message on a message broker. Here, it's depicted as Kafka, and that was the original implementation. Originally, Debezium only worked with Kafka. Then there appeared some other message brokers that are actually compatible with Kafka, like Redpanda. Or if you use Apache Pulsar, you can use a plugin, Kafka over Pulsar. But also there are some new developments. For example, just yesterday, support for RabbitMQ streams was released. All right, so Debezium publishes each change event on a message broker in a way that is accessible for our software. It's either JSON, Avro, or something like that. Let's see how it looks like. Here is an example in JSON. Such an event has schema information. This is important because the tables change over time. Their structure changes over time. If we didn't carry the schema information, we would be coupled only to one representation, and we want to allow evolution. Okay, there is also payload. Inside of the payload, we have the before part, which tells us what the record was like before the event happened. After, what was it like afterwards? As we saw, before was null, it didn't exist. After, it has some fields, so it was created basically. And we can confirm it was created because the operation is C. For Debezium, it means it's a create operation, and it corresponds to then insert. So an insert happened on the source database, and we can consume such an event, such a JSON event. Okay. There is something more we would like to say about Debezium, is that it can operate in one of two modes, either snapshotting or streaming data. So streaming data is exactly what we just explained, basically following the transactional log and emitting events as new transactions happen, basically in real time. Snapshotting is a little bit different. So let's say you just want to hook Debezium into your existing database. You probably have a lot of data over there, and most likely you would like to expose all the existing records on the message broker and start following the updates. So reading the existing data is what is called snapshotting. All right, that's it about change data capture. So
let's talk about the capture part. In our case, we are bringing data from one relational database model into another one, and we do it with Elixir. So you can imagine that there is some generic part of the code that we wrote related to this process, and some specific code characteristic for a particular database table. All programming languages help to deal with generic code and specific implementation by some form of polymorphism. So, real quick return to basics. Polymorphism is a Greek word meaning multiple forms or shapes. So just like in this picture, there are multiple fruits that you want to transform into vegetables. Don't ask me why, but for the sake of this presentation, we want to do that. So there is likely some generic action that you need to do common to all fruits, and some particularities, for example, for a banana. In an object-oriented language, you would model that with interfaces. But Elixir is a functional programming language, and it doesn't have interfaces. Instead, Elixir has behaviors and protocols. In our project, we use both of them. So let's take a look at them one by one.
Okay, so behaviors. Modules that represent a source database in our application, they need to implement the source schema behavior. And it has two callbacks. One is schema, so it's similar to the schema in Ecto. If you're modeling your table with Ecto, then you have a schema macro that you use, and then it means the name of the table that you are mapping. Here it would also mean the name of the table on the source database, but it would also mean a part of the topic name. Then there is another callback called Schema Level. It returns 0 or a higher integer. What is it for? Well, we will talk in more detail in the last part of this talk, ordering. So it helps us to consume data in the right order. For now, let's reveal a bit of this. So if this callback returns 0, it means for us that it's a top-level table, which means it doesn't have any foreign keys, any dependencies on the other tables. It can be consumed right away. If the value is 1, it means it has some foreign keys, but the related tables are top-level tables, and so on. In our application, this number grows up to 4. But again, we will talk a little bit more about it in the last part. Okay, now the protocol. So for each of those source schemas, we implement a protocol that is responsible for handling change events for it. And that's it. Basically. We didn't start from actually implementing this with protocols. We had one huge module with a lot of pattern matching, and it really became a little bit messy. So we migrated the code to using protocol, and we thought maybe it's useful for somebody. That's why we share it. Anyway, apart from behaviors and protocols, we have regular modules and functions that implement some common concerns, and those are ensuring idempotency, ensuring consistency, as well as error handling. This talk is only 25 minutes long, so let's scratch out the one that is not important at all, error handling. Who cares? Just joking. Actually, we will talk a little bit in the last part about error handling, but also the truth is we don't have so much time. So let's start from idempotency. Why do we even need to care about that? Well, we are consuming messages from a distributed message broker, just like Kafka or an alternative. And those distributed message brokers, they do not have exactly once delivery guarantee. All we get is at least once. So we can always receive the same message twice or even more. That's why we need to make our consumer idempotent. The general strategy is to implement something like a processed messages table, basically to remember all the messages that we have already successfully processed, and if we get another such a message again, we just ignore it. And that's how we do it. We identify the message by its topic name and offset. Okay, consistency. In our case, we are writing to a relational database. So of course, we achieve consistency by using transactions. In Ecto, this can be done by one of two ways, either by using Ecto multi-struct or by the repo transaction function. And as you can see, we prefer the latter one. The reason is we are not limited only to the Ecto functions that operate on the Ecto multi-struct. We are much more free. So that's why we do it. Okay, probably it seems quite easy so far, and actually it is not so complicated. So let's see if we faced any challenges.
And spoiler, we did. A lot of them were about orderings. That's why it has its own dedicated part in this talk. So in the context of our application, each message broker topics correspond to one database table. It can be something else on other places, but for us, it corresponds to the database table. So if your data set is not huge and you don't partition data within topics, then that would mean that you are guaranteed to receive operations happening on database table in an order as they happen. If you do partition data, then that would mean that messages will be ordered within each partition. In Debezium, the partitions will be created respecting the primary keys of each table. So, for example, all change events happening on a particular user will always arrive to you in the correct order. And that is enough when dealing with data on a single topic. But how many of you work on databases consisting on only one table? Not many, I guess. So what about messages between different topics? Well, there are no guarantees here. You may receive a message corresponding to a child table before receiving the message emitted for its parent table. And if you want to model this relationship in exactly the same way in your target data store, then you may have a problem. No. You could be tempted by just giving up on foreign keys and store data in the target database that may point into non-existing records. That would be really messy, and we didn't choose to take this compromise. We value data consistency granted provided to us by database, and we like to find out about issue early, so we can fix them or at least hide them. So how did we solve that?
All right, so there is one easier way, kind of a workaround. Let's say we receive a record of a child table before receiving a record of the parent table. We don't have yet the parent there, so inserting such a record wouldn't work. But there is an easy workaround. We can just put this child to sleep, wake it after some time, hoping that the parent has already arrived. If not, we can repeat the sleep and wake up process a few times until we give up. So that's a workaround, and it works for us. So why not use the easy way? You lose a little bit of latency because you're putting this child to sleep. Maybe it's sleeping a little bit too long in vain, who knows? But yeah, it's not complex. But, sorry. That's the wrong slide. I just described what we do for streaming. But when we are streaming, that's what we do. But when we are snapshotting what is on this slide, it's a little bit easier because we can just consume all the records of the parent table, then all the records of the children table or its children table, and so on. But that's only the case if if all of those events were emitted during the snapshotting phase, and if the Debezium is not actually streaming the new changes at that time. So you can do that. You can do that to batch the writes to make snapshot ingestion much faster. But you need to be careful. You only can do that for read operations. And as long as you have create operations, update, and delete, you should rather go one by one with consuming those events. And that's the strategy you can use. You can put the child to sleep and then wake it up after some time. But that's not the only way to go around that. We are very fortunate because we have powerful Elixir and OTP. We can do much fancier solutions. So let's say we receive a child record before its parent. So instead of putting this child to sleep, we could spin up a dynamically supervised gen server called, for example, parent waiting room, place the child over there. As soon as the parent arrives, we could use something like Phoenix pops up, notify the child waiting there, and directly insert the child records. So far, we didn't go that route because the latency issue is not an issue for us. But it's really cool to have access to this advanced technology at your fingertips. Okay. So that's most actually of this talk. And we think you may be actually asking yourself a question. Will you ever need change data capture? So it may seem kind of cool. It may seem like it solved some particular issue for us, which was implementing a Strangler fig application, replicating reliably all the data from the legacy system to our new application. But is change data capture useful in general, or it's kind of an overkill for you? So to answer this question, we will try to quote few wise people. So first, Greg Young, the author of the CQRS pattern, he says that it is not possible to create an optimal solution for searching, reporting, and processing transactions utilizing a single model. Now, I think it doesn't always hold true, because sometimes your system is really simple. And also the data volume is not so huge, and the traffic is not so big, and probably you can go around with one correct data model. But as soon as the complexity grows and use cases grows, you may need to store one piece of information in different systems. Maybe a cache data store. Maybe Elasticsearch to do some full-text searching. And in these cases, change data capture can be really helpful. So let's see what Martin Kleppmann has to say about change data capture. If you're not familiar, he's the author of the book Building Data-Intensive Applications, which is kind of a Bible when it comes to databases and distributed systems. So he once says that change data capture is like a magic wand, which makes certain problems in building systems simply go away. So those certain problems is exactly saving the same information in multiple places reliably. Okay, if Martin Kleppmann is not enough of an authority for you to consider change data capture a possibly useful tool in your toolbox, let's ask a more reliable source, ChatGPT. Change data capture is like a proficient alchemist, expertly blending the elements of data consistency and real-time synchronization, transmuting the complex challenges of distributed systems into a refined elixir of seamless integration. Okay. Okay. So thank you very much. Now it's time for questions.
Thank you both. Yeah, we already have one back there, another here.
Hi, have you tried alternatives to Debezium?
Have we tried what?
Alternatives to Debezium.
No. Do you have any like particular in mind?
Yeah, I know Maxwell, but it's way more lightweight.
No
experience.
Yeah, I know there are some even in Elixir libraries that you can with which you can follow. For example, the Postgres WAL. But for example, for us, we needed to support different databases, MySQL and Postgres. So that's one of the reasons Debezium is the solution for us. Yeah.
Okay. Was it the case, I mean, the case that you gave was quite a complex example where you were trying to preserve referential integrity across two disparate database systems. In a practical sense, the word, for the majority of people doing what you're doing, would it be more natural to go from a normalized database schema to some kind of denormalized representation of the data? Did you ever consider using something like CRDTs on the receiver side to incrementally augment the entities which you're replicating in?
Yes, so I think there are two parts to your question. One is like the normalized representation, and the second one CRDTs. So we didn't consider actually. We didn't want to change that much the source structure. That's one that maybe answers the normalization. About CRDTs, again, I don't think it would. I think it might not be even possible because there are many limitations what you can do actually with CRDTs, and I think the complexity would be much bigger. Yeah.
Okay. Yeah. Thank you so much.
Thank you. I think we have one in the front, another here.
Hello, thank you for the talk. Have you considered using Kafka streams to work around those ordering issues instead of Elixir?
Yeah, well, we are Elixir shop, so actually for us it's easier to use Gen servers to go around those issues. Actually, it's not so complex in the end. Yes, so actually introducing a new language to the team, I think it would be more complex. Yes.
Okay, thanks.
Yeah, thank you.
Oh, yeah.
Hey, thanks for the talk. It's amazing work, guys. Did you consider for the ordering issues to put very much related data together in the same topic and then use partitioning keys to keep all the data related to the same, let's say, user or entity in the same partition?
Yeah, thank you. That's a great question. So again, the answer is like we didn't want to modify that much our source. We wanted to respect it and not do much changes on the source database to which we were following. But actually, something like this we will probably do very soon, because the system which receives this data also will serve as the source for other systems soon in the future. We plan to use the transactional message outbox pattern, and it's quite likely that yes, we will include some rich data there in such messages. Thank you. Yeah.
Cool. Anyone else? No. So yeah, let's give a big round of applause to Michal and Vanessa.